All right, welcome back. We're going to be picking up where we left off from yesterday at 1.4 Physical Revolutions as Major Milestones of Development of Natural Science. The history of the development of natural science, and in particular, physics, shows that such crises in natural science have already happened more than once, and each time they were solved stereotypically by introducing a new hierarchical, hierarchical level. In order to find a way out of this impasse, to resolve the accumulated contradictions, and to advance in fundamental and applied research, it is necessary to recall that all the most important results of classical physics were obtained on the basis of a dynamical approach, in which each structure is assumed to consist of moving parts, and each of the parts even smaller ones. The movement of these parts and their interactions in concrete cases as a concrete phenomenon. The movement of these parts and their actions in concrete cases is a concrete phenomenon. The description of the external sides of the phenomenon and the dynamic approach is only a consequence, not the main content of the phenomenon as it follows from phenomenology. The dynamic approach implies the possibility of creating illustrative physical models at all levels of the organization of matter. The dynamic method proceeds from the assumption that each structure is made up of parts and each part is made up of even smaller parts. The movement of these parts and their interactions, let's see, the movement of these parts and their interactions in specific cases is a concrete phenomenon. The dynamic model in nature has always, the dynamic method in nature science has always justified itself. The main line of development of natural science has always been a step by step deepening into the structure of matter, transitioning into deeper and deeper levels of its organization. Each such transition meant a radical breakdown of old ideas and other physical revolutions. Uh, let's see, breakdown of old ideas was another physical revolution and provided a way out of the crisis. Oh yeah, so the only way out is to throw everything out and start over again or whatever. Start a revolution. Start it all up from the ground up again. All right, and such each transition gave to mankind. Yeah, so every time things were scrapped and rebuilt, new stuff, rebuilt. However, each such transition did not occur by itself, but under the pressure of the accumulated new facts, the explanation of which turned out to be impossible within the framework of existing theories. The resulting crisis, the resulting crisis situation could only be solved within the framework of the mastered hierarchical level of material formations. But it was quite simply, but it was solved quite simply after a new, deeper higher, deeper hierarchical level of organization was introduced into consideration. It is noteworthy that practically all physical theories up to the beginning of the 20th century had physical models as their basis. This is understandable because any phenomenon has countless properties and it is impossible to describe them all at once. After all, even such a simple device as a weight suspended on a thread makes a complex makes a complex motion and can be, depending on the purpose, described in the variety of ways as a pendulum in a gravity field, as the torsion pendulum, or finally as a spring pendulum. And and this is not yet counting the combinations of all those motions, interactions with the environment, internal processes, etc. All of this was well understood by physicists of the 18th and 19th centuries. Oh, I'm sorry, through the 17th and 19th centuries. Yeah, 17th and 19th centuries. In fact, the dynamic method has its origins in the deepest antiquity. In this time, the German dialectic philosopher Hegel, in his Principles, speech speak to a gymnasium of students, made this comparison. Just as Antaeus rewound his just as Antaeus rewound his strength by contact with Mother Earth, just as every new dawn and increase of science and enlightenment arises by turning antiquity. So yeah, by turning over a new leaf, you're good to go. Very cool. For all this rich imagination, Hegel could not imagine the impact of science in the 20th century on all the spheres of life. In the 19th century, the interest in antiquity was almost always in the domain of the humanities. In order our time, natural science itself became seriously interested in ancient thought. First of all, in its leading fields, physics and mathematics. As science penetrates more and more deeply into the structure of matter, it is found to be following in the footsteps of ancient philosophers. It is useful to recall that for, Dalton, for example, borrowed the word atom from Democritus, an ancient Greek materialist philosopher, and from him we now have borrowed the word ammer to denote the invisible part of the atom, which is the molecule of ether. And it is the word itself that came from us from ancient times. Very cool history lesson. Oh yeah, forgot to highlight stuff. There was a couple of things back here that I wanted to snag real quick. I can come back to it another time. All right. To be fair, though, to be fair, although we consider the origin of science to be from the ancient Greeks, in fact, this is certainly not the case. Although we consider the origins of science to be from the ancient Greeks, in fact, this is certainly not the case. Democritus repeatedly emphasized that he was not the originator of atomism. This knowledge he borrowed from an Egyptian priest named Midian, or I'm sorry, from Egyptian priests and Midian magicians, the mighty, from whom he interned for 5 years. The roots of science lie in the deepest antiquity of which we know practically nothing. Nevertheless, throughout the history of mankind known to us, it has been accompanied by unconventional secret knowledge, which has even received an independent name, esoteric. So yeah, the esoteric hidden knowledge and all that. However, continuing the tradition, we will start considering the formation of science from Thales, Thales of Miletus, who lived in the 6th century BC and who already then posed the question, if all of nature is unified, what is the basis of unity? He believed that nature, at the basis of all phenomenon, has a certain unified medium of wet nature, period. Otherwise, how could they interact and influence with each other? So yeah, so this guy thought that everything was, intrinsically bound together by a fluid-like medium. Otherwise, how could pressure mediate between them to cause an interaction? So I think it's really interesting that, in that regard for pressure mediation, that who was the guy that put forth Copernicus? So Copernicus, in his model, he said that he thought that the sun was singing a heavenly song, and that the orbits of the planets was facilitated by pressure mediation of the acoustic waves from the sun's heavenly song. And that's very beautiful and profound when you realize the implications of, a vibrating field, ether mechanics, and like where it stems from and why, and sound and vibration and all that. And even in these ancient times, like these concepts of a medium needing to facilitate the pressure mediation between two objects is, I mean, it's quite profound, I think. And I think that's uh, a really cool uh, way to word it, because that it sounds crazy, right? Like if we look at that now and with our scientific knowledge of space time bending and all that sort of stuff. Sorry, I got distracted. I was reading a message really quick. But yeah, if you look under it through the modern lens, right? They're like, what? Like the sun singing a heavenly song that's Facilitating pressure mediation, like what are you talking about? But that's like, you know, it's pretty accurate, pretty hot take, you know. Let's see here. So this question has accompanied natural science, although let's see, influence with yeah, okay. So this question has accompanied natural science throughout its history, and only now are we getting the first opportunity to approach an answer to it. The history of natural science is inextricably linked to the history of the whole society, and each type of development of productive forces technology corresponds to a corresponding period of history and natural science. The first stage of develop. Let's see, how do I make this? Fit, auto fit. There we go. The first stage of development of natural science is considered to be uh, preparatory. Is considered to be preparatory, natural, natural philosophical, and is a characteristic of antiquity. In general technology, it is still underdeveloped. Oh, in general, technology was still underdeveloped, although we were already, although there were already some outstanding technical achievements. This stage can be attributed to the period from the 6th century BC to the, or I'm sorry, yeah, the 6th century BC to the beginning of the new era. Although realistically, it can be considered extended to the beginning of the second millennia of the new era. In the 5th century BC, Empocles, Im, Empeda, Empecalo, yeah, who knows, dude. So Empedocles, and in the 4th century BC, Aristotle a proposed to proposed to decompose all nature into substances: earth, a solid; water, a liquid; air, a gas; and fire, energy. In fact, he introduced the aggregate states of matter and energy, which ensures the transition of matter from one state of matter to another. The Chinese added wood, life, to these four substances, and the basis some and this basis and on this basis some analysis of the physical state of the substance became possible, and philosophy was born. Aristotle's philosophy lasted in Europe for about 2,000 years. So yeah, this was a pretty big big brain moment when they started categorizing these things and breaking down, matter and the different states of matter. That's cool. Lasted for 2,000 years. They're like, holy shit, did you guys hear about your boy Aristotle? Like, nah, man, that's 1,500 years ago. Tell me about it, though. This transition itself was stimulated by the desire to realize the world which man lived in and his desire to understand his place in nature. It was impossible to do this without appropriate analysis. The task to understand the aggregate states of bodies first came, and when philosophers of antiquity singled out this problem, they introduced concepts of substances, and then and on this basis and began to develop philosophy, and already allowed the formation of independent branches of knowledge such as statistics, astronomy, and mathematics. Alchemy began to form, although it should be recognized that in all this there were also echoes of the most ancient esoteric knowledge, about the essence of which we still know almost nothing about. Medicine and physics were still in their infancy. All natural scientific knowledge and views were included in a single undifferentiated science under the aegis of philosophy. The differentiation of the sciences for the first time appeared at the end of the period closer to the Middle Ages. The very transition from a unified nature to nature substance marked the first revolution in natural science. The second age of the development of natural science is considered preparatory as well, I guess, or preparatory. It can be attributed to the 10th and 8th centuries AD, i.e., to the Middle Ages. to a period of development of feudal relations. Is characterized this stage is characterized by the dominance of theology in Western Europe. Science in the West became an appendage of theology and religion. By this time, there was an urgent need to save the people from numerous epidemics which literally mowed down the population of Europe. So, what was that? Paracascalus or Philip von Hohenheim, a prominent physician of the Middle Ages, believed that all human processes are chemical processes and that all disease are related to disturbances in the composition of substances. His method and treatment of the addition of missing chemicals to a sick body laid to the foundation of pharmacology and the drugs of science. Wow, very fascinating. Not going to touch too much on that subject, but that is very cool. These applied tasks required dealing with substances. The transitions in natural sciences from substances to substances was the second revolution in natural science. The progression of technology in the West was extremely slow. Technique did not yet need systemic study of nature and therefore did not have a noticeable influence on the development of natural scientific knowledge. But even at a time, but even at this time, there was already accumulation of new facts that prepared the transition for the next period. The third stage of development in natural science is called the mechanical and metaphysical. This stage lasted from the second half of the 15th century and lasted till the end of the 18th century. This is the time of the establishment of capitalist relations in the Western Europe. This stage is associated with the transition from substances to the molecule, small masses. Natural science of this period is revolutionary in its tendency. Here, the natural science of the beginning of the 17 wait yeah 17th century. Let's see where was I at? These small masses. Natural science in this period is revolutionary in its tendencies. Here, the natural sciences in the beginning of the 17th century, Galileo at the end of the 7th century, and the beginning of the 18th century, Newton is distinguished. Metaphysics became the dominant method of thinking, but even then, discoveries were made in natural science that revealed dialectics, i.e., development. Natural science was connected with production, transforming from a craft into manufacturing, and energy, and the energy base of which was mechanical motion. Hence, the task to study mechanical motion and to find its laws. Natural science was mechanical because all the processes in nature were applied exclusively to the scale of mechanics. The introduction of the idea of minimal particle and matter molecule contributed to the emergence of mechanics and the material point. Newton, a direct or from Newton, a direct consequence of which hmm, a direct consequence of which was the invention by him and Leibniz of mathematics of the analysis of the infinitesimal qualities. To the same time belonged the creation of analytical geometry by Descartes, I don't know. The cosmological hypothesis of Kant and Laplace, as well as the ideas of development and biology from W.K. Wolf, which prepared the next stage. In the early 18th century, a Russian scientist named M.V. Lomonosov formulated the concept of the corpuscle, the minimal amount of a substance which was later called a molecule. This gave rise to the development of chemistry. At the end of the same 18th century, French chemist A. Lavoisier introduced the concept of elements, the simplest substance from a combination of which any substance can be created. Transitions from natural science to the substance of molecules, name the molecule, name of the molecule, uh, later or appeared later. The third revolution was in natural science. This transition gave a more powerful impetus to the development of chemistry. The period of the late 18th and early 19th century characterized by the beginning of the rapid development of capitalism on the basis of the Industrial Revolution. So yeah, farming all the raw materials and raw chemicals and processing oil into base chemicals to be redistributed to everyone. Yeah. So that's what kicked everything off, and they were like, "Yo, there's money to be made here. We can run this anyway." There was a need for dyes and fabrics, so there was an increased interest in chemistry. But the development of chemistry was impossible without the following transition of the depth of matter. Therefore, the transition from the molecule to the minimal particle of a simple matter was made, which in 1884 which in 1824 was called the atom by an Englishman named Dalton, and the name borrowed from Democritus. By atom was meant to be the minimum amount of element, further indivisible from Democritus. This transition This transition gave rise to the development of chemistry and electromagnetism. Physics and chemistry came to the fore, studying the interconversion of forms of energy and types of matter. At the same time, the limitations of water engines became clear, and the engines were that were required could use the and engines were required that could be used in any terrain under a wide range of conditions. The invention of the steam engine gave rise to industrial capitalism, and industry entered the phase of large scale machine production. But the steam engine did not completely satisfy production either. There was a need for a compact engine that would be installed in any room and even on individual machines. This gave impetus to the development of the first electrical en- of the first This gave impetus to the development of electrical engineering, which had an opportunity the to develop using achievements of chemistry. At this time, the theory of the slow development of Earth emerged in geology, while theory, paleontology, and embryology were born in biology. In the th- in, in the second third, not the first third, but the second in the second third of the 19th century, they saw an emergence of the cell theory and the doctrine of energy transformation and Darwinism, which dealt a blow to the old metaphysics, forcing us to consider substances and processing in their development. So yeah, there was a huge transitional paradigm shift in there to stifle out the metaphysics part of everything that led to the revolution of like breaking down what is matter, which led to chemistry, which then allowed them to kick off the industrial revolution. Pretty crazy. And then they were like, no, 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 stop studying metaphysics. The transition to atomism was followed by the discoveries that revealed dialectics of nature, the creation of theory of chemical structures of organic compounds. A.M. Burr Butlerov, 1861. The periodic system of elements from D.I. Mendeleev, 1869, and electromagnetism, James Clerk Maxwell, 1873. The transition from the molecule to the atom was the fourth revolution in natural science. From the end of the 19th century, capitalism entered the stage of imperialism, which entailed the arms race, in which advances in physics and chemistry and emerging electrical engineering were essential. The stimulating effect of new technical needs on development of natural science led to the fact that in the mid 1900s, new discoveries appeared mainly in physics. The discovery of electromagnetic waves by H. Hertz, shortwave radiation by K. Roentgen, radioactivity, the electron, and the introduction to the idea of quantum by Max Planck, and the creation of the theory of relativity by Einstein, the invention of the radio by A. Popov, chemistry, the development of the periodic tables. I think did it like translate that twice? Yeah, it sure did. All right, cool. So the guy with chemistry again, Mendeleev. The late 19th century, where the 20th century saw the emergence of the notion of elementary particles of matter. In 1887, English researcher J. Thomson proved the existence of the first elementary particle, the electron. In 1911, E. Rutherford put forward the planetary model of the atom, on the basis of which the 1913 and 1921 in which in which 1913 between in which between 1913 and 1921 appeared the ideas about the atomic nucleus, electrons, and quanta. The proton was discovered by him in 1919, and in 1932 the neutron was discovered by J. Chadwick. Further, the wide range of elementary particles of matter was obtained, which led to the development of the atomic energy. Bohr developed Rutherford's model on the atom, and in fact, that moment, quantum mechanics began to develop rapidly. The next revolution in natural science was paralleled by this. The fifth revolution of natural science was the introduction of the elementary particle of matter into consideration. Was the introduction of the elementary particle into consideration, and this led to the advent of atomic and subconductor technology, or semiconductor technology. In the 20th century, the development of physics, atomic energy, radar, radio electronics, communication, automation, and cybernetics, quantum electronics, lasers, electronics, optics, etc., was accelerated. Physics, as a leading branch of all natural science, began to play a stimulating role in relation to the other branches of natural science. For example, the invention of the electron microscope caused a revolution in all biology, uh, physiology, and biochemistry. Physical methods determined the success of chemistry, geology, astronomy, and contributed to the development of space science and space exploration. In biology, deepening the cell structure led to the creation of genetics and molecular biology. In chemistry, to polymer chemistry and cybernetics, and to computer science began to develop on the basis of semiconductors. Thus, the fifth revolution in natural science led to a revolutionary leap in technology, the NTR. I don't know what that is. The the scientific and natural technological revolution. So the scientific and technological revolution. I must have used the wrong letter there. The main task of chemistry becomes the synthesis of polymers, rubber, and artificial fibers, productions of synthetic fuel, light alloys, and metal substitutes for aviation and astronautics. The energy base of the industry in the 20th century became increasingly electric. The dynamo machine, chemical engineering, internal combustion engines, and after the Second World War, atomic energy, which we all know worked out slightly differently than how they had planned, and it turns out atomic energy is a really efficient way, or nuclear energy is a really efficient way to boil water and turn a turbine engine. The transition to the new deep level of matter and organization was also preceded by a crisis expressed in the misunderstanding of the variety of variants of properties in the mastered material formations. Introductions of the building material of the already mastered level helped to understand the structure of these formations. Thus, the introductions of molecules helped to understand substances, atoms, molecules, elementary particles, atoms. The crisis was overcome. This crisis was overcome. All perplexities were solved. Science received a new powerful impetus of development, but starting to point was always applied needs. Properties and behavior of material formations became clear if material formations of the deeper level were introduced into consideration. The transitions to a new level always meant that a radical breakdown of the previously established ideas was another physical revolution and provided a way out of the crisis. Figure 2.1, don't have anything to show for that. To explain the chemical transformations, atoms, and constituent parts of molecules and chemical compounds were the constituent parts of molecules and chemical compounds were introduced into the theory. And when it became clear that atoms transformed into each other, the concept of atoms emerged, elementary particles of matter of which atoms were composed. At the same time, the properties of higher level matters of organization became clear. It turned out that material formations of senior hierarchical levels differ from each other first by a set of elements, material formations of the formation of the junior hierarchical level. At the same time, the younger formations, for example, atoms or elementary particles, were endowed at first with only the simplest and most essential properties for which even reflected the name atom, meaning indivisible, in elementary particle, i.e., meaning the simplest, like the most basic foundation building block. You can't get any smaller. With the accumulation of the experimental data, the ideas about the inner essence of the phenomenon changed, and the physical models of these phenomenon changed accordingly. The change in models entailed the changes in the equations describing the phenomenon. They're like, oh no, dude, you still think it's the old way? Have you seen the new equation, bro? They took out the permeability. Like, oh no way, bro. Revealing the structures, understanding the internal mechanism created an opportunity for directed action. Directed action research was organized. Directed action research organized new methods appearing. The increase of the number of fields of the senior level varieties did not scare anyone, as it was clear how it all happened and why. Completely new perspectives of theoretical and applied research and applications were opening up. The next physical revolution demonstrated to the world its qualitative new possibilities. The new possibilities immediately became the property of applied science and served mankind. It is also necessary to pay attention to the fact that all physical revolutions fully corresponded to the provisions of dialectical materialism. They proceeded from objective facts, assumed the independence of nature from the methods of its research, implied the inexhaustibility of matter in depth, and all processes and phenomenon occurred with uncreated and indestructible matter in Euclidean space and uniformly flowing time. However, at the beginning of the 20th century, there was a fundamental change in physical methodology, along with deepening into the structure of matter through the use of ideas about the elementary particles of matter in physics, and after it practically in the whole natural science, there was a refusal from the methods of classical physics in the study of nature. If the classical physics reduced a complex phenomenon to a set of components, this The essential phenomenon was determined by the movement of the matter at levels deeper than the phenomenon in question, and the explanation of the essence of the phenomenon was reduced to tracing a cause and effect relationship between the parts of the phenomenon, and then theoretical physics, or yeah, trace between tracing cause and effect relations between the parts of the phenomenon. Then theoretical physics, born in the early 20th century, posed the question in a fundamentally different way. Quantum mechanics and the theory of relativity, after them, all fundamental natural sciences refuse to consider internal processes of phenomenon. Everything began to reduce to phenomenology, external descriptions of the phenomenon and their mathematical descriptions. So called postulates, free assumptions, which, according to the authors of postulates, are supposed to correspond to nature, were massively introduced into practice. Very cool. This approach to the study of natural phenomenon could, let's see, where are we at? This approach to the study of natural phenomenon could not but lead to an increasing divergence of the theories from reality, which resulted in a crisis of physics and with it the whole natural science. However, it can be stated at this present time there is a situation typical for the eve of other revolutions of natural science. By the mid 1960s, numerous statistical data had been obtained on the elementary particles of matter. It turned out that all elementary particles of each of each consisted of each of all others, i.e., the transformations of any particle as a result of their collision into any other particle can be obtained. Yeah, classic. On the other hand, there is no information about the internal structure of these elementary particles themselves, because as a result of the postulative approach of quantum mechanics and theory of relativity, the building material of particles, the ether, the world medium, was thrown out of consideration. Facts, brother. Facts. It appeared that the main obstacle for progressive development in natural it appeared the main obstacle for development in natural science. Furthermore, advancements in the depth of matter requires a return to the methodology of classical physics, a return to the concept of ether, which was an obligatory attribute of natural science throughout its history up to the beginning of the 20th century, which allows to solve this crisis. Thus, natural science is on the eve of the sixth revolution, which will give impetus to an extremely powerful development. Today, we can only guess about the consequences to which it will lead. Presumably, it will be a complete solution of energy, resources, and ecological problems, and possibly healthcare and more. However, it should be noted that, as in the previous revolutions of natural science of the sixth transition to the hierarchical nature of the organization of matter, requires revision of the foundations of existing natural science, preservations of everything that corresponds to the new task of rejection of what is superfluous, artificial, not corresponding to the real nature of physical phenomenon. One second, my throat's getting dry. All right. Let's see. The development of natural science occurs in stages. Each stage is connected with mastering of the deeper and deeper levels of organization of matter in this next physical revolution. Oh, yeah, I have a thing here for this. The physical revolutions of natural science. Shoot. I think I have that translated somewhere. I'll have to double check it. But I think that this is this. Um, nope, that's not it. No. I'll look that up later. Okay. Sorry, I wanted to see what the natural flow was here, but I'll have to check it out later. Today in science, there is a typical solution. Many so-called elementary particles of matter have been obtained in various experiments. All of them are able to transform into each other, which testifies to their common building material. Fact: the vacuum is able. The vacuum is able to with a certain combination of electromagnetic fields. Nice. Okay. The vacuum the vacuum is able to the vacuum is able to with a certain combination of magnetic fields give birth to elementary particles, but testifies both that the vacuum and the force fields have the same building material as their basis. Boom. Fact: as as the vacuum is infinite, it means that the whole world space is filled with a building material, and that the material has always been has always been called ether in nature. In science, it should be called ether as well. I mean, dude's he gets it. All right. And the element of ether, aka the indivisible element of the atom, was called amber in ancient times, and this name must also be assigned to it. Now we should now should we not now considering the number of considering that the number of elementary particles is already from 200 to 2000 depending on how one counts, that all of them are capable of being changing into one another and apply the same method, except Lane's word that the electron is inexhaustible as the atom, nature is infinite, and the direct instruction to the action and allow the existence of even more elementary particles as a direct instruction. I don't know. The elementary particle that makes up the so-called the elementary particle that makes up the so-called it's written backwards. Sorry, it's just a translation situation right here. The elementary particles of matter, which are actually complex entities. Oh, okay, so you're saying are these elementary particles actually just complex entities? I guess, such a particle should be called emir because that is what Democritus called it. In his opinion, emir, a particle of an atom, is truly indivisible. Is truly the indivisible particle of matter, and the aggregate for it, emir, is ether, the medium that fills the entire world space and is the building material for all kinds of matter. Thus, it is necessary to return to the question of existence of the ether, its structure and role in nature. By the end of the 19th century, in natural science, by the end of the 19th century, natural science had largely defined its position. Physics already then considered the basis of natural science had defined its position. The two significant moments remain not quite clear. Inconsistency of experimental data with calculative curves in the part of the black body radiation and non-detection of the ether wind in Michelson-Morley experiments. However, it soon became clear that these inconsistencies gave rise to a completely different or to a complete scientific catastrophe in the collapse of those provisions that formed the basics of classical physics. The results of the proceedings was a change in the apparent study of nature and the goals of all natural science. Well said. All right. The Modern theoretical physics moving on to section or chapter 1.5 on the meaning of militant materialism today. Modern theoretical physics prides itself on its peculiarity, its complexity, and its elitism. It is often impossible for a mere mortal to understand what theoretical physics states, as this allows the theoretical this allows the physical theory itself to avoid criticism from applied physicists. It also separates it from applied problems and creates conditions for the creations of a special clan of theoretical physicists, to which people from the outside are no longer able to join. Thus, the problem from a scientific or thus the problem from a scientific one grows to a social one. What is the reason for all this? The reason is in the methodology which the physical theory adopted at the beginning of the 20th century in the counter revolution, not a revolution at all, which took place in physics, and in which Lenin devoted his famous work of materialism and empirio-criticism. In fact, and the fact that the main methodological technique in physics was the advancement of postulates. Yeah. What is a postulate? According to the Great Soviet Encyclopedia, 3rd edition, volume 20, page 423, a postulate is a proposition that for some reason is accepted without proof, but as a rule with justification, and it is the justification that usually serves as its argument in favor of accepting the postulate, sparing no arguments designed to convince us of the reasonableness or the validity of the postulates we propose. We ultimately simply demand its acceptance. That is, neither more or less. We demand it. That's all. Wow. That's awesome. Yeah, and since 1900, when Max Planck put the first postulate, physicists has been inventing postulates to their opinion to which about which nature must conform. One second, I gotta clip this out. Oh man, and then okay. So Einstein's special theory of relativity is based on five postulates, of which the main one is the declarations of the absence of the ether in nature. And this postulate is based on the false understanding that the absolute fringe patterns were zero. Yeah, exactly, man. So crazy. Yeah, that's nuts. All right. So Einstein's special theory of relativity is based on five postulates, of which the main postulates is a declaration of the absence of ether in nature. This postulate is based on the false understanding of the results of the first experiment of Michelson, who allegedly obtained a zero result when measuring the ether wind, i.e., nothing, which is false. The general theory of relativity of the same author adds these five postulates and five more, and the last one is a categorical statement of the presence of ether in nature. Oh yeah, yeah. So that was where Einstein said that the general theory of relativity without the ether was unthinkable. Quantum mechanics has taken all the postulates of the theory of relativity and added to them nine more, and quantum field theory four more. But the total number of postulates that have found shelter in the physical theory have been counted already many dozens. Has already counted many dozens. Oh, but the number of postulates that have found a shelter in the physical theory is counted already many dozens. All the stuff that they've tacked on to keep it afloat. Very nice. And then under the invented and not at all properly substantiated postulates begin to fit the facts, which in the purest idealism with which limit which and then under the invented and not at all properly substantiated postulates begins to fit the facts, which in its purest idealism with which Lenin successfully tried to fight. Theoretical natural science followed the idealistic path, and as a result, it led to the modern crisis in natural science. In recent decades, idealistic ideas of nature in various kinds have been gaining strength in natural science. The question of the synthesis of science and religion is officially raised. The question of synthesis of science. Let's see. I'm not to conclusion. Are we about to get to another chapter yet? Okay, yeah, we are. Okay, I'll wrap this up because I'm getting kind of bored on the history here. But we're almost at an end. Okay. Let's see. Creationist theories about the creation of nature and the establishment of its wise laws by a supreme God are being revived. In other theories, the concept of God is already replaced by the so-called the theories the theories that one of the categories, matter in space or time, should be excluded from consideration at all because it's possible to do without them. On the other hand, theories appear that one of the categories, matter in space and time, should be excluded from at all because we can do without them. Ener- energ- Electromagnetism attempts to reduce matter, or no, I'm sorry, ener- energetics, energeticism attempts to reduce matter to energy, which in fact has long been done in theoretical physics and physical idealism, according to which nature can be invented and which has been long dominated. Theoretical physics are revived. However, all this testifies not to the correctness of the idealistic trends, subjective or objective, which are being recalled from oblivion, but to the insufficiency of materialistic philosophy, which has not yet succeeded on creating an appropriate methodological foundation for the development of materialistic science. Damn, that's a nice quote. That all this stuff keeps coming back in cycles because they haven't even come up with a good way to analyze it and stick to the scientific method. The exclusion of the ether as a building material of the microcosm deprived physicists of the possibility to analyze the structures of the micro objects to understand the origins of their properties and the results of their internal motions of matter, which made them prefer phenomenology, i.e., external descriptions of the study. Yeah, we should write that down. Phenomenology. Phenomenology. All right. All of this led to the complete misunderstanding by physicists of the structure of material entities, elementary particles of matter, atomic nuclei, atoms in their electron shells, as well as their interaction fields. This immediately imposed restrictions on the possibility of studying the real world and spread to areas of naturals, and this spread to all areas of natural science. The whole problem of the ether should be treated from these positions. By throwing out the theory of the ether, the medium that fills all the world space and is the building material for all kinds of matter, physicists deprive themselves of the possibility to penetrate into the depths of matter to find out that the structure to find out the structure of material formations and the structure of interaction fields. They have fetishized a few postulated mathematic dependencies, declaring they know everything. That's a great quote. I like that one. They have fetishized a few mathematic postulate dependencies, declaring that they know everything. They have been treading on the ground for many years without discovering anything new and increasing the capacity of experimental facilities in the blind hope to get something new at the expense of it. However, nothing new has arisen in years and can be confidently said that it will not arise because without understanding the internal structures of the material formation and the internal mechanisms of the phenomenon, there will remain only the method of scientific poking, which is very unproductive. It's an awesome quote. By rejecting the ether, physicists have robbed themselves, excluding the very possibility of the further penetration of the depths of matter. The problem of recognizing or denying the existence of the ether in nature goes far beyond the formation of the private physical theory. Recognition of the fact of the existence of the ether as the world medium must essentially and inevitably concern all kinds of material formations, all physical phenomenon and processes, consequently the whole world of natural science. However, to no less extent, to no less extent, to no less extent, the recognition or negation of the ether in nature also concerns the entire philosophical basis of natural science and through this entire philosophy of science as a whole. And now it is actually a question of restoration in materialistic positions in physics and throughout the whole of natural science. Lenin attached a great importance to the ideological struggle for this introduction of the ideology of materialism and atheism into the masses. We must understand, he wrote, that without a solid philosophical foundation, no natural science, no materialism can withstand the struggle against the onslaught of the uh, Burgios ideas of the Burgios ideas and the restoration of the Burgios worldview. I don't know what that means. In the emergence of a materialistic theory of natural science, the materialist methodology arising from it, the most interested today are the applied scientists who face the most important task, the solution of which directly affects the future of mankind. These are, of course, the problems of energy, ecology, technology, space security, raw material supply, durability of materials, food supply, healthcare, and much more. These problems can be solved only by the understanding of objective laws of nature and the structure of material entities at all hierarchical levels and the organization of matter, understanding the internal processes of the phenomenon. Consequently, applicants need a materialistic theory that reflects objective reality and not the inventions of cabinet scientists. It is through applications that the main front of struggle between materialism and idealism passes. There could be no compromise. There can be no compromise in the struggle because too much depends on its outcome. Conclusion 1. The crisis of physics in the late 19th and early 20th centuries was expressed in the failure of a physical theory to realize the numerous new experimental data obtained by many researchers at the end of the 19th century. This was due to the dogmatic attitude to the theories at the available time and to the idealization of the quote unquote well tested physical laws obtained by time and had to lack in and the lack of understanding of the inner physical essence of the phenomenon that the laws were describing. The leading theoretical physicist of the time found a way out of this situation in increasing the abstraction in the increasing of abstraction from reality, in the creation of abstract models, the prevalence of mathematical models over physical content, in the postulation of an initial position for construction of theories. It was of this temporary success of physics and at the time of the preparation of the new crisis. So yeah, that temporary band-aid that they put on where they all unified under this great banner of space-time, was that temporary solution which led to where we're at right now. It's really well said. Modern theoretical physics is in a deep or two. Modern theoretical physics is in a deep crisis expressed in its increasing ability to assist applicators in unsolving urgent technological problems in the ever increasing at the ever increasing cost of research. The reason for this is the entrenched idealistic ideology according to which it is allowed to put forward postulates, neglect the factual material, replaced by the physical essence of the phenomenon with spatial and temporal distortions, i.e., rejecting the materialistic philosophy of the absolute philosophy of absolutization of a few laws and, in fact, a few mathematical expressions. Change the methodology of theoretical physics in the direction of idealization, widespread application of postulates, axiomatics, fitting of the experimental data to fashionable theories is not a revolution as it is presented by theoretical physics and philosophers, but a counter revolution. Oh, that's an interesting way to word it. It was a physics counter revolution. In physical revolution, 3. Real physical revolutions in natural science have always been the generalization of the accumulated experimental induction on the basis of revealing their general properties and the basis of the transition to a deeper hierarchical level of the understanding of the organization of matter. Involvement in deep levels of matter allowed to consider the matter of this new for the next stage of natural science, the level as the building material formations of the previous senior level. This resolved the accumulated contradiction and opened new directions of research and deduction. 4. The way out of this impasse is possible only through the return to materialistic ideology, to the goal of natural science, and nature should be understanding that the cause and effect relationship between material objects and phenomenon. This means that a dynamic method which implies the presence of structures in any material bodies and internal mechanisms and phenomenon, thereby recognizing the inexhaustibility of the depth of matter and the fundamental possibility of the understanding of the internal mechanisms. Let's see. Sorry, I got a little sidetracked. I'm really trying to just finish this. I don't even remember where I was at. Material structures for the physical phenomenon. Was that five? No. Five. Nowadays, there is a necessity of the transition of the next level of matter organizations of the elementary particles. This transition is a transition to the recognition of the existence of nature of the ether, a medium that fills the entire world space, is a building material for all kinds of formations and movement of which are manifest in the form of various interactions of material structures and physical phenomenon. Six, as always, in crisis situations, the ideological struggle in theory between materialism and idealism is unfolding. The materialistic direction is supported by and developed by those who face the actual applied problems on the idealistic direction. The idealistic direction is associated with attempts to preserve the position of the outdated theories that are not able to help the applicants in solving practical problems. However, as always, the idealistic direction is doomed to defeat. Natural science is on the eve, and the next physical revolution is inevitable. Very nice. All right, let's see how long we've been going here. We're looking at an hour here. All right, let's tap into chapter 2 here. Let's read a little bit in chapter 2, and then we'll probably close it out for the night. Chapter 2, A Brief History of Ether. The unified ether permeates the entire universe. And that's an ancient Chinese Taoism quote or idea or whatever, allegedly. Chapter 2.1, A Brief Overview of the Theories and Models of Ether. Okay, so now we're going to get into the ether. Cool. Or the history of it, rather. The necessity of a critical examination of the numerous pre-existing hypotheses, models, and theories of the ether arises from the fact that despite the correct initial premise that the interaction between bodies must be conditioned by some immediate medium, the ether, none of these theories of the ether have been able to satisfactorily explain the totality of all known phenomenon. On the other hand, it has not allowed to predict any new directions of research on the other. As a result, not only these theories, models, and hypotheses were discarded in the course of development of physics, but also the very concept of the ether as utterly discredited. Let us consider the main concepts of the ether that existed in natural science to try to analyze their positives and disadvantages. Despite the fact that a number of researchers on the history of the ether and development of the physical concepts attribute the introduction of the idea of the ether to natural science to Rene Descartes and the idea of atomism to Democritus, it should be considered that both concepts of the ether as a world medium and the concepts of atoms and elements were known long before that and accompanied almost the entire history of human civilization. First and foremost, it should be noted that all religions of the world, one form or another, recognize the existence of some invisible supernatural sacred power underlying all existing world. The belief in the reality of such a power and the desire to cognize it and find a connection with this mystery and omnipresent force is one of the most important aspects of any religion. Citation 1. And then Alexander Menn in Contemporary Christian Theology describes this unknown force in the following way. The Algonquin Indians, under the name of the Manitou, honor the super worldly forces. or worldly force. We find that the ideas of the Malalayans inhabitant. We find ideas of it in the Malalayans inhabitants. This has power. This has a certain supernatural character. This power has a certain supernatural character. It is called mana. In Papanis, this mystery force is called the Omnin, Omen. I don't know. Onim. According to the Australian Aborigines, there is a certain Wagnar, the eternal. Dude, that's crazy. That's crazy. According to Australian Aborigines, there is a certain Wagnar, an eternal, irresistible, impersonal force that manifests itself in the days of creation and continues to have a fruitful influence on life today. With the American peoples, too, we find the notion of mana in the inhabitants of the Western Sudan. Her name is Nalia. In the Pygmies, Megabe in the Zulus, Anumu in the Ugandans, Jock, or possibly Yak, in the northern colonies, Elima. Let's see. The North American Indians have a very interesting and deep meaning about the ideas of the supreme being. The religious belief of the Dakotas, writes one researcher, or beliefs of the Dakotas, writes one researcher, are not deities of such, but in the mysteries of in a mystery unrecognizable, something of which there are incarnations, but the greatest object of worship is the Taku Wankan, whose supernatural and mysterious powers. This power, called Orenda by the Iroquois and Wagnar by the Ulalorndi Gulers, pervades the whole of nature. Wow. Crazy, man. So they're like all of these cosmologies were also flat earthers, if I'm not mistaken, from the or they were all enclosed dome cosmology people. So yeah, they all knew the Earth was fixed and that there was an ether. That there is an ether. Let's see. How much more do I have to read? I'm kind of not in a mood to read tonight. Oh, it's a bit. It's a bit. Yeah. All right, we're gonna call it a night on this one, and we'll pick up on another night. Page 49. Okay. Cool. So we'll pick up on page 49.